Alright, go for it.
Okay. So for question 3, the true linear regression for gene for y equals 0 plus b1x, for b0 and b1 are known. What are the known alternative hypotheses for b1? And so that will be b1 equals 0 and so then it would be b1 does not equal 0. So we see. Question 4, the residual is the difference between the observed value y and the value predicted by the regression line. Question 5, a plot of residuals reports using linear regression when the residuals look normally distributed. Question 6, compute the residuals for the data using software. What statement best describes the residuals? The residuals are between about 40 and 25. Question 7, based on the QQ plot for these residuals, what can we say about these residuals? The residuals are fairly normal. In question 8, using software to create a scatter plot of the data given the scatter plot residual plot and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data. So it's the first 3 that we check. There's linear relationship between x and y variance with error. So it's consistent for all values of x, and the residuals are normally distributed. Question 9. What is b1? The estimate for the slope, and it's 12.695. And the lower bound is 10.674. And the upper bound is 14.715. Question 12. Based on the evidence in using level of significance alpha equal 0.05, what decision would you make regarding the hypothesis test for B1? And it is reject the null hypothesis test because the p-value is less than alpha. Then 13, for the hypothesis test for B1, if you reject the null hypothesis, what does this mean? There is sufficient evidence to conclude that the slope of regression line is not 0. Question 14, for this data, which variable is the dependent variable? Is the body length? Okay, a margin of error is 0.443. Lower bound is 7.218. Upper bound is 8.103. Question 18, based on your lower bound and upper bound from the last 2 problems, what can you say about B1? We are 95% confident the confidence interval will contain the true value of B1.
Alright.
There you go.
Cool.
Okay. We are ready for 24?
Yeah.
Okay. So question 2, which of the following variables is or are quantitative? Just the last one, the number of people in a randomly selected classroom on campus. Question 3, students in an introductory statistics class at BYU, Idaho were studying prices of cold cereal at grocery stores in Rexburg. To get a sample of cold cereal prices, they went to Albertsons and rolled a die to decide which box from the left of the top shelf they would start on. They recorded every 6 cereal after the first, moving from left to right down the shelves, recording the name, size, and price of each cereal in their sample. Is the study an experiment or an observational study, and why? It's B, an observational study, because the students had no control over the price of the individual cereals. Question 4, for a M221 project, one group of students studied the age of students on the BYU Idaho campus. They collected data from a random sample of 100 students. The sample mean was 21.2, and the sample standard deviation was 2.61. The group notices an error in their data. The age of one of the males was entered incorrectly. He's actually 21 years old. When the error is corrected, what will happen to the sample median? It's the third choice. It is not possible to determine this without the full data set. Question 5, the time to complete a standardized exam in the BYU Idaho Testing Center is approximately normal, with a mean of 70 minutes and a standard deviation of 10 minutes. Using the 68, 95, 99.7 rule, approximately what percentage of students will complete the exam in under 50 minutes? So that answer is going to be 2.5. Question 6, the scores on the LSAT are approximately normal with a mean of 150.7 and standard deviation of 10.2. Queen's School of Business in Kingston, Ontario requires a minimum LSAT score of 157 for admission. Find the 35th percentile of the LSAT scores. So for this one, the 35th percentile, which you plug into the normal probability applet, is negative 0.385. So you just equal that to 157, 7 divided by 10.2, and you just solve that, and you should get 146.8. Question 7, a team of researchers were studying skin cancer among 60 to 70-year-old American men. Suppose you were part of the research team and take a sample of men from this age group and calculate the mean number of skin cancer spots in the sample. Also suppose that it is known that the distribution of the number of cancer spots is right skewed. Suppose the sample size for the study was 2. What would the shape of the distribution of sample means? And that would be skewed right. So question 8, suppose that a simple random sample of 20 tanks is selected and the sample mean capacity is found to be 8,550 gallons. What is the z-score corresponding to this sample mean? So that's going to be 2.236. 9, what is the probability that the sample mean capacity of 50 randomly selected tanks will be greater than 8,540 gallons? And that's going to be 0.991. Question 10, which one of the following best describes the notion of the significance level of a hypothesis test? That would be the second one, the probability of a type 1 error. Question 11, the heights of young adult females in the U.S. are said to have a population standard deviation of 2.6 inches. A sample was taken of 85 young adult females at BYU-I, and the mean was computed to be 65.4 inches. Which of the following explanations describes the correct way to interpret the 95% confidence interval for this problem? And that would be the third and the last one. Question 12. Marine biologists have been studying the effects of acidification of the oceans on weights of male beluga whales in the Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. The researchers want to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Their data follow a normal distribution. The population standard deviation of weight of male beluga whales is 125 kilograms, and the researchers feel comfortable using the standard deviation for their confidence interval. Are the requirements for this use of confidence interval met? That would be B, yes, the distribution of sample means is normal because the data are normal. So 13, you just open up the rates of return. So to find the p-value for this, you just conduct a one sample t-test, and then you have to half that because we're looking at a less than value. So it's going to be 0.019. 14, a financial economist is studying married couples in which both spouses work. He wants to compare the median income earned by husbands with the median income earned by their wives. Should he use independent sampling or dependent sampling? The second one, dependent sampling, he needs to select couples for the samples. Whether a particular wife is included depends on whether her husband is included. So 15, the p-value for this is going to be 0.096. And then for 16, we're going to say the first one, no, because the p-value was greater than the level of significance. And then 17 is just we're looking for if the requirements are met, are satisfied for this. And it's going to be the third one, yes. The distribution of mean differences is normal because the data have been determined to be normal. And then 18, the most appropriate hypothesis, pair of hypotheses for this test would be the third one, where the null equals 0 and the alternative is not 0. And then 19, suppose you create a 95% confidence interval for a mean and you get negative 2.346 and 8.775. You've been told to report this by saying we are 95% confident that the true mean is between negative 2.346 and 8.775. What does this mean? It's the second one, 95% of all 95% confidence intervals actually contain the true mean. And 20, if p equals 4.5, what is the smallest value of n? That would be 50. And then 21, your little brother has a career batting average of 0.233, and you want to determine the probability. That would be over 0.250. So are the conditions met? And that'd be the last one, no, because 40 times 0.233 is less than 10. So then for 22, which of the following is the most correct interpretation of this statistic? And it's the last one, 51.2%. The sample have the male chromosome. And then 23, for this one, you're just going to take, you need to find p hat, which is 320 divided by 750, which is about 0.4266. You need to find the standard deviation, which is about 0.018. And then you take 0.43 minus 0.4266 minus 0.45 divided by the standard deviation. You should get the negative 1.285 and apply that into the applet. And then just highlight the left side, and you should get 0.099. Then 24, which one following is the p-value of your hypothesis test? It's going to be 0.182. Then 25, suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purified Cocker Spaniels. It is known that the distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to be sure the sampling distribution of X is normal? And that would be the last one any N will do. So then for 26, are the requirements satisfied to form this hypothesis test? And the last one, no, because in at least one case, the sample size times 1 minus p hat is less than 10. So 27, the correct alternative hypothesis would be the second one, where it does not equal 0. And then for 28, it's just going to be the second one. His actual weight loss was 5.5 pounds higher than his predicted weight loss. And then 29, for the study in the previous question, the B1 of the regression line was 5 pounds. Interpret the statistic. That's the third one. As percent compliance goes up by 1% on average, 5 pounds are lost in 3 months. And then 30, creating a boundary plot, a residual plot, and a QQ plot, which are the 5 assumptions about linear regression are being checked. That'd be the second one, the third one, the second, and then the last two. And 31, you just plug this into SPSS, and you should get 0.78 for 31. And then 32, with a fairly strong positive association. 33, the y-intercept you should get 115.64. For 34, the slope should be 0.627. And for 35, you should get 240.9. And then 36, what is the lower bound? It's 0.518. And what is the upper bound? 0.735. And the margin of error is 0.109. And for 39, the correct null alternative hypotheses is the last one. The value of the test statistic is 11.509, and the p-value is 0. And then the decision we make for 42 is we reject the null. There is sufficient evidence to suggest that the slope of the true linear regression line does not equal 0. We conclude that there is a linear relationship between 14-day ticket prices and 90-day ticket prices. So 43 is going to be one sample t-test. 44 is a one sample z-test. 45 is a test of one proportion. 46 is a test of two proportions, and 47 is linear regression.
All right.